Alright, so in this video, I want to be showing you how the area of an equilateral triangle can be determined. Everyone believes that the area of any triangle, area of any triangle is what? Half base times what? Height, which is true, right? But what we want to do is we want to show that for an equilateral triangle, the area, which is the same thing as half base times height, is equal to what? A square root what? 3 over what? Over 4. Now, one unique property of an equilateral triangle is the fact that all the length of each of the sides are equal and each of the internal angle are what? Are 60 degree, right? So each of these is 60 what? Degree. So our focus now is to determine the area of this equilateral triangle. So now let's assume that the length of each of this side is A. So let's say this is A. Let's say this is A. And let's say this side is also like I've put it. So all I want to do is I want to show that A square root 3 over 4 is the what? Area. And it also follows this same logic. So for us to be able to achieve this, we are looking for half base times height. Obviously, the base is A, right? So we need the height. So basically, the height will now be the perpendicular bisector of this vertex. So let me use another color. So if we bisect this particular vertex, so we are going to be having 90 here, 90 here. So if the length of this full side, let's say this side is let's say this is A, let's say this is A, B, and C. So basically the length of AC is also A. So from A to, let's say this is what? M. So A to M will be what? A over 2. And this one will also be what? A over what? 2, because we have bisected what? B. So we can actually choose triangle ABM so as to determine the what? Height of the equilateral triangle. So we now say from triangle ABM, from triangle ABM. So we're going to be having something like this. Let me use my ruler. It's going to be like this. Okay. From triangle ABM, we're going to be having something like this, okay? Yeah. So we're going to be having something like this. All right. So this is A, right? This is what? A over 2. And this is the height that we are looking for. We don't need the angle, basically. So we can actually use Pythagorean theorem to get the height. So this is 90 degree. So by Pythagorean theorem, Pythagorean theorem says that, don't forget this is ABM, pardon me for that, that the square of the hypotenuse, that's the hypotenuse, the side facing the right angle, is equal to the sum of the square of the other two sides. So we can say that what? AB square is equal to what? AM what? Square plus what? Plus BM square. So what is AB square? That is what? A square is equal to what? AM. That is what? A over 2 square plus what? BM. That is what? H square. And don't forget, H is what we are looking for. So this will be what? A square is equal to what? A square over what? 4. How? So if we take the square root, A square, so A square, then 2 square will give us what? 4. Then plus what? H what? Square. So if we make H square the subject formula, what we are going to be having is we are going to be having, A square minus what? A square over what? 4 is equal to what? H square. Basically, if this one comes in. So I can say that what? H square is equal to what? A square minus what? A square over 4. So this is over 1. So let's find the LCM. So if we find the LCM is what? 4. 1 in 4, 4 times A square, that is 4A square. Minus 4 in 4, 1 times A square, that is what? A square. So 4A square minus A square, that will give us what? 3A square, right, over 4. So basically, H square is equal to what? 3A square over what? 4. So take the square root of both sides to cancel this square. We can say that H is equal to what? Square root of what? 3A square over 4. And that is like saying square root of what? 3A square over what? Square root of what? 4. So that will give us what? This is like also saying square root of 3 times square root of what? A square, right, over square root of 4. That is what? 2. All right, so then at the end of it, we are going to be having what? H will now be equal to what? Square cancel square root. So we only have A left here. A times root 3. That will give us what? A root what? 3 divided by what? Divided by 2. That is the height. So having gotten that, so let's come back to what we have here. And what is the area? Area is half base times height. So we can say that what? Area, which is equal to what? Half times base, right, times height, right, will now be equal to what? 1 over 2 times, what is the base? The base is A. There's no need to check. Times A times what is the height? That is what? A root what? 3 over what? 2. So if we do our calculation very well, A times A times root 3, that would be what? A square root 3 divided by 4. So for an equilateral triangle, we can therefore say that area is equal to what? Half what? Base times what? Height, right, which is the same thing as A square root 3, right, over 4. Now, don't forget that this is only valid for an equilateral triangle where A is the what? Length, right, of the what? The side, because the side of an equilateral triangle are of equal length. All right, so that is that. For instance, if a question says that what is the area of an equilateral triangle of length of side 4, so we know that implies that A is equal to what? 4. So we can say that area will now be what? A square root what? 3 over 4, and that will give us what? That is 4 square root 3 over 4, and 4 square, that is 16 root what? 3 over 4. 4 here, 1, 4 in 16, 4. That will give us 4 root 3. That is if we're given such a question. I just use that as an illustration. I want to believe this video has helped someone. Please don't forget to subscribe, like, share, and most importantly, subscribe. Thank you for watching my video. See you in the next video. Bye bye.